Alright, MS-DOSX, let's get started. Today's lecture should be hopefully pretty quick. I'm going to talk about a fairly broad concept that's really not necessarily unique to Objective-C. It's kind of a broader software design pattern called delegation that's used a lot throughout Cocoa and Cocoa Touch. And you'll see why it's a really powerful way to design software. And it eliminates the need for a lot of redundant code. So let's start off by just defining what delegation is. So we have this word in English, delegate, which is to basically to tell somebody else to do something on your behalf. And that's more or less what delegation is from the software point of view. Apple has this great document called Cocoa Core Competencies that has basically every term that Objective-C that the Cocoa classes use defined in a really nice way. And their definition for delegation is that it's a really simple pattern in which one object or program acts on behalf of some other object, which again is basically the same as the English definition of the word. So you may wonder why this is kind of useful. A slightly more precise definition is that there is one object that's doing the delegating, and it sends messages, it keeps a reference to some other object. That object is the delegate. Usually pronounced delegate, actually, but just to be clear with the pronunciation. And when certain things happen, the delegating object sends messages to the delegate. And that message tells the delegate, hey, some event happened, you should do some processing on this. Or maybe some event's about to happen and you should be prepared to handle something. That delegating object, or the delegate can then respond to that message either by, usually what will happen is it'll update the appearance of the UI, it'll update the model somehow. It can also optionally return some sort of value back to the delegating object, indicate success or failure, or some other value that the delegating object needs to indicate what happened with this event and how it got captured or not captured. So an example of a delegate is the NSWindow class defines a protocol called NSWindowDelegate, which defines a series of methods, one of which I'm going to talk about is called window should close. And every time the user presses the close button on a window, the window calls on its delegate the method window should close, which returns a Boolean value, yes or no, whether or not the window should close right now. So if you want to, for some reason, not close a window, say, for example, if you have saved state that you want to make sure that the user saves before you close the window, you could say, no, actually, I don't want the window to close right now. I want them to make sure that they save before they close the window. So you can use this to kind of intercept close calls and be able to handle close events in a clean way. So delegation is actually a really simple idea, but it allows for some really powerful customization of objects without the need for subclassing. Cocoa and Cocoa Touch define something like 100 protocols called something delegate. And the vast majority of those are in AppKit and UIKit, which are the GUI parts of the foundation frameworks. So a lot of this comes into play when you're customizing the appearance and behavior of your user interfaces. And like I keep saying, it eliminates the need for subclassing in most cases. So delegation is best learned by example. So I'm going to go through a few example delegation protocols and kind of show you some example code. The lab, which will not be today but will be on Thursday, because we're going to combine that with some other topics that we talk about on Thursday, will give you a lot of really hands-on practice with implementing different delegates for different controls. So one delegate that you've hopefully seen before is NSApplicationDelegate. This is the delegate object for an application, as the name suggests. And the idea is the application will call methods on this application delegate when certain interesting events in the application lifecycle happen. For example, application did finish launching. This gets called on the delegate after the application is launched and allows the delegate to do any other additional setup of data or views or windows that the application needs once it's been started to set some things up. This gets called right after the main loop has been made, but before any events get sent to it. So you can be safe and know that you haven't gotten any events yet, so you can do any setup so that way when you start getting events, you're ready to handle those. On the other side, you have application should terminate, which will be called when the quit command has been chosen, either from the menu or from the keyboard. Most of the time, you want to quit right away, but you can actually delay it or cancel it if you want. The documentation describes kind of what you should do if you need to delay it or cancel it. There's sort of a handshake that you need to go through to make sure that you actually do in fact terminate soon, but you don't have to do it right away if there's some dire need for you to stay alive for another few cycles to finish writing the disk or something. Yeah.
When does, like, relatively speaking, applications in finish launching and await from nib? What order do those occur?
That's a good question. I'm not exactly sure.
I think application did finish launching. That happens after await from nib, since I think application did finish launching happens after all the zip stuff and all the objects have all been initialized. And your application is like, okay, so now your application is ready to run. It's ready to rock and roll all the data.
Waiting for the nib to still launch.
Yeah, I believe if you go through the documentation of all these methods, I think they make it pretty clear, more or less, what the order is in. There is sort of a protocol among the system classes of what order these get called in, and I'm pretty sure the documentation explains that. But yeah, I believe did finish launching doesn't get launched until everything is ready to go, which includes loading up nibs and things. But that's a good question, because sometimes getting that order is important for your code to make sure that your code is doing the right thing. So a little bit more about will terminate. The most common use of will terminate is to do some last minute cleanup. Generally, you're just going to quit right away, but there are ways for you to suspend quitting, or delay it, or cancel it even. But generally, you'll provide an implementation for will terminate, and that's where you can do some cleanup. If you have some set user preferences you want to save, you can save those out to disk, and we'll talk in a few weeks about what you can do to save user preferences. I think Apple keeps making it easier and easier with applications, especially with Lion, having sort of transparent application state, much like on iOS. But there's some stuff you can do to make sure that you save your application state before you quit. Some other useful ones are will become active, did become active, will resign active, did resign active. So on OS X, only one application really has active status at any one time. That's that application that they currently, if you look in the app switcher, that's the one that's currently, the leftmost one, that's the one they're currently working in. So these get called as part of the process of entering and leaving, becoming the active application. So if you have some really expensive animation that maybe you don't need to do when the user's in some other application, you can dial that animation down in one of these methods and then fire it back up when you become active again.
Is that the same as frontmost?
No, not the same as frontmost, because that's for Windows. But that's important if you have multiple windows. There's a method on I think it might be window delegate, it might be just window, for keeping track of when you become the frontmost window or when you become not the frontmost window, so that we can do the same thing there. So you notice that all these methods we've seen so far, they take as a parameter this NSNotification object, which sort of, the idea is it encapsulates everything about this event, or whatever it's launching, terminating, becoming active, and such. In particular, one thing you can query that notification for is the application in question. So it's very rare, but if you really wanted, you could have one application delegate run multiple applications. I don't know why you would ever do this, but you could. And it can query that notification to figure out which application is the one that launched or which application is the one that terminated. And there's a lot of other information that notification includes. So feel free to read the documentation to kind of see what you can get out of those notifications. So we also have, OS X has the ability to hide applications, so to kind of make it disappear from the screen. So there's will hide, will unhide, and did unhide that get called as part of the process of hiding and unhiding. So applications have a menu that you can put in that appears in the dock. If you right-click the application icon in the dock, you can provide your own menu to insert into that to do some custom behavior. So there's a lot that OS X gives you for free. There's things like minimize and show me all the windows that this application currently has running, and hide and things like that you can do from the dock menu. But if you want to be able to do some other things from the dock menu, you can insert a menu, which is the same kind of object as, say, a file menu or an edit menu, same kind of object, but it draws it differently and all that. And so if you want to do that, you can have some behavior for when the dock icon gets compressed. You can also specify that in a nib if you want, but this is a way to provide it dynamically if you want it to change based on whatever the context of the application currently is. So there's also things like application open file, open untitled file, which is kind of a way of making a new file. So these get called when they ask for opening a file or for making a new file. They return. So we see here that these ones return a Boolean value, which is kind of a way to indicate success or failure. So if you try to open a file that doesn't exist, you can return no, saying that open failed. If for whatever reason when you try to make a new file you can't, you can return no there too to indicate that there's failure. Okay, so I have a really short demo that uses NS application delegate.
Await from nib does get called before application did finish launch, for exactly that reason, to make sure that all the objects are ready to go before your application actually starts.
Okay, so I have this kind of skeleton application called, it's just a real simple RSS reader. Right now, when it launches, not really much of anything happens, but I can go up to, say, file open feed, and I should get a feed URL. Let's go to Safari. Oh my god, it's small. Let's just grab their RSS feed. And I need to change it to HTTP. And it doesn't do anything except really change the title of the window. But for now, what I want to do is when I launch, I want to show that open window, because as soon as I launch, I probably want to immediately query the user for what RSS feed they want to look at. So let's, inside of application did finish launching, I have a nib reference to that window, and I'm just going to say, tell that window to become the key window, which we'll talk about a little bit more in more detail when we talk about events, but that's the idea, is that's the window that receives keyboard events. Make key in order front, so make it the key window and put it in the front. And self is just the object that asks for this. So now when I run, did finish launching gets called, and it tells that window to come into the front. So obviously this isn't a particularly sophisticated thing to do in launching, because this is a pretty simple app, but you can imagine using that to initialize any state that you need while the application is running. I also could have done that in the interface builder, but I didn't. I wanted to kind of have an example to show you. So that's that one. Another one I'm going to talk about is NS window delegate, which, as you can imagine, is the delegate object, is the delegate protocol for a window. And I'm just going to go over again some interesting methods on that from that protocol. So to handle resizes, rather than have to subclass the window and have the window programmatically determine how to redraw itself when it resizes, I can just use a standard window class and define a delegate for that handles that resize behavior. So there's window will resize to size and window did resize. And so these get called as part of the resizing process. The kind of neat thing is that window will resize returns a size. So it passes in a size that this is the size that I'm going to try to resize to, but if you don't like that, you can return another size. So if you want to enforce that the maximum size is 800 by 800, and you get a size of 900 by 900, you can say, no, actually I want 800 by 800, please. So that's a really clean way for you to custom kind of programmatically change the behavior of the resizing, so that way you can, without having to define anything special about your window, you can just say, okay, when I get this size, that's the size I want to be. I think you've seen this already, but just so you're familiar, the NS size is a struct that keeps a width and a height. It's pretty simple. So these methods will always get called, even if you programmatically resize the window. So any time the window resizes, these will get called. So that's useful if you want to make sure you just want to enforce some restrictions on the size of your window. Window will miniaturize, did miniaturize, and did deminiaturize are called as part of minimizing the Wint application. So when you're minimizing, if you're doing something really expensive, you probably don't need to be doing something expensive, because if the user minimized your app, they're probably not going to be using it very heavily right now. So you can slow down some animations and that sort of thing. So you can use these methods to start and restart, or stop and restart certain processes that are expensive that you don't need to be running when the application is minimized. With Lion, now we have these really great full-screen applications, and it's pretty easy for you to leverage that. There's just a bunch of methods on this window for did enter full screen, will enter full screen, will exit full screen, and did exit full screen for you to do any custom redrawing of your views or whatever you need to do to make your full screen application look beautiful. So most of the time, apps use this to kind of rearrange their views when they become in full screen, because if they're full screen, they can use their real estate a little differently to kind of really take advantage of the entire screen. So these kind of keep track, will get called for you as long as your application reports that it allows full screen using the new system. These will get called on you by every time the application enters or exits full screen. If you're interested about the position of the window, you can say window will move, window did move, and if you're working with a multiple display application, you can even find out when the window changes screens, when it goes from one screen to another. So yeah, those are all, I hope, pretty straightforward. They just get called all the time when the window gets moved around. So if you want to do, I don't know why you'd ever do this, but it's like some custom reinforcement of the window does certain things in different corners of the screen or something, but you could do that if you wanted, because you can, maybe you can't, I don't know if the notification, I'm not sure what's in that, but it might contain the location that it's moving to. Which would be kind of cool, because if you could do some navigation that looks differently in different parts of the screen. The ones I think that are sort of the most commonly used are window should close and window will close, which are sort of analogous to application should terminate. So these will get called, like I mentioned earlier, when the close button gets pressed on the window, and allows you to customize this closing behavior. Interestingly, window should close doesn't get called on all of your windows when the user quits. That's a different behavior. I'm not quite sure why they do that. So, but the idea is that these only get called when there's an explicit attempt to close a window, either by a user or by you. And like I mentioned, the should close returns a Boolean, so you can indicate, actually, I don't want to close right now. I need to do something before I close. And so that will intercept the close for you. Okay, so a simple demo for that. So again, this is a sort of contrived example, again, but that's okay. So just to kind of give you some example code of how to. This doesn't make a lot of sense for RSS, but suppose this has some state that we want to save, and we don't want them to close when they have unsaved data. I think this is less of an issue with Lion and autosaving, but whatever. So I want to hook into this close call, so that way, if there's save state, that we don't actually close. So I'll show you some code for doing that. So this is the controller object for that window, and what are we going to do here? Okay, so here's our window should close method, and I'm just going to pretend that there's always save state that we need to save. So it'll always prompt the user to save before they close the window. So I'm just going to make an NS alert. You can pass in the message that you want, and then some labels, some text titles for all the buttons you want to have in that alert, and then maybe some more informative information. And then I'm just going to tell that alert to, this is pretty much the method you call to attach that alert to a window. And then I define this selector that it will call when one of the buttons get pressed, so that way I can determine what button got pressed and behave accordingly. So we'll implement that method here. You'll notice that it takes the alert that sent this. It takes a return code, which basically is going to indicate to us which button got pressed, and it also includes a pointer to any object if we needed to pass in any additional information to this call. In this case, we don't really need anything, so that's just we're going to ignore that. So when we created the alert, the other button was said don't save. So we don't want to actually close the window unless they say, actually, I don't want to save. So go ahead and close. So if the return code is the other button, then we'll close. Okay, so now if I try to close, I get this alert. If I say cancel, then we don't close. If I say save, then we don't close because we would need to implement some sort of saving operation. I'm not going to go into that, but there's lots of great code for how to do that. But if I say don't save, then it closes. Cool? Any questions about that? Okay, so another delegate protocol that gets used rather a lot, actually, is NSURL connection delegate. So to explain why we use this, I'm going to kind of try to motivate this. So applications pretty frequently need to get some sort of data from the web. This is often done using HTTP requests. So these examples are grabbing things from some web service or some, like grabbing tweets from Twitter or anything like that. That there's some HTTP request you make, and you get back some, say, JSON object or some XML object that you need to interpret, and then that's how you get your data. Relatively speaking, these requests are pretty slow, and generally apps shouldn't block the main thread with long requests because an application that's blocked is going to be unresponsive, and an unresponsive application is going to frustrate the user because they're clicking on things and they don't know why it's not working because under the hood it's doing some requests on the internet. So as a result, and like I said, a UI that's unresponsive is not a very good UI. So the solution is to make these requests asynchronous. That is, that they sort of run on their own background-y process sort of a thread, and then when certain events in that URL's processing cycle happens, they're going to notify the object that made the request. So the idea is you make an NSURL connection object, you pass it a URL request, which in most cases can just be a URL wrapped up in a string wrapped up as a URL. And then that URL connection, its implementation is go run off on a background thread, and when interesting events happen, let me know. And the way we do that is through a delegate. So you specify a delegate on this URL connection, and when interesting events in the lifecycle of this connection happen, they call messages on that delegate. So the first interesting event is when the connection receives any response at all. So that's they send like a ping out to the server saying, "Hey server, are you alive?" And it gets back some response. Officially, it gets called when the connection has received enough data to construct the URL response for the request. Formally speaking, basically that's just saying once it's ready to get going, it sends this. Then there's the one you use mostly is did receive data. So these requests possibly can be really big. So every time it receives a certain, like a chunk of data, it calls this. And NS data is this really general data class that encapsulates pretty much anything, and you can encode it and decode it however you like. And so if you have a really big request, you'll get a lot of these calls, and you can just keep appending them to some local data structure that you have, and just keep tacking more and more on. And once you're done, then you have the entire data response all in one. And lastly, there are did finish loading, which is when everything is done and it completed successfully. And then connection did fail with error gets called if at some point in this connection there's some sort of error, either your internet died or the server gave a bad response, gave some sort of server 500E type error. It's guaranteed that once you get one, you'll get exactly one of these, and after which you'll get no more messages. So you can use both of these to clean up and make sure that you're done handling all of your delegations. So our RSS app probably needs a URL connection if it's going to try to grab all this RSS data from our RSS feed. So we'll go in here. When we start, when this window gets created, it first calls set feed URL, which passes in a URL object for wherever the URL of the feed that we want is. So the first thing we're going to do is we're going to create a URL request, which is pretty easy if you have a URL object. You just give it the URL. NSURL request is actually pretty general. You can tack on a lot to the HTTP headers. You can insert images and all kinds of data into this. Mostly, it's pretty common just to use them for just making some URL request, but there's a lot more that you can actually totally customize the HTTP headers if you need to. And then we're going to create a URL connection. That was wrong. And then we're going to create a URL connection with that request and set the delegate to be self. And that creates that thread and then immediately starts running it, assuming that it works. So if they're actually, and then this is just a little sanity check. If that connection succeeds, then I'm going to create an result data, which is an NS mutable data object, and I made it mutable so that way I can just, as I get more data, I can just keep tacking onto it without having to reconstruct a whole data object. I can just kind of append to it. And if not, then I'm going to log out some error message. Okay, so that gets it started, and then we need to implement the protocol NSURL connection delegate. And those I put up here. So the first thing we're going to get is hopefully just one, but possibly multiple did receive responses. The common wisdom is every time you get one of these, you need to reset your data because it's basically you're getting a totally new response. It's pretty uncommon that you get more than one of these calls, but if for whatever reason the first packet failed, you might get multiple of these because the first one didn't connect properly. So every time you get one of these, you want to basically nil out all your data. That's not super interesting. What is a little more interesting is when we receive data, we're gonna tack all that data onto our result data. Just keep appending it. Once we get all of these, and hopefully by the end we'll have built up the entire data for the request. And then lastly, we have these two methods for cleaning up. So if it failed with an error, we want to release our data because we alloced it down here. So we want to make sure that we always release the memory that we allocate. We can release the connection because again that got allocked here but never released. So we're going to release that here, and then we're just going to present that error message to the user. Okay, and then lastly, if the connection succeeded, and I'm going to talk about this in a little bit but the idea is that if you haven't seen it before, XML. Actually, I'm going to comment this out for a second. Let's just so that you guys can see this response. I'm just going to create a string from that data and then print out and then log out the string so that we can see the data. Create a string. Init with data, result data, and then the string encoding. Since it's coming from the web, it's most likely going to be UTF-8. It's going to be Unicode. So there's a parameter NSUTF-8 encoding to say that's the encoding scheme that text is going to be in. And then I'm going to log out that string. And yes, this is leaking, but we're not done, so it doesn't matter. Okay, so let's run that and see what we get. So I say open, and we have something on the console. Let's see if it's what we're supposed to get. So we have this great big long XML document. If you haven't seen RSS before, it comes down as XML. So the next thing we need to do is parse said XML into usable data, and that's where NSXML parser comes in. So there's Cocoa has a really great built-in XML parser for you, and it works in kind of an interesting way. It doesn't. So it has this great class for building XML. And a lot of XML parsers will try to build up the entire, because XML under the hood is the structure of an XML document is basically a tree. It's this tree of tags within tags within tags and so on. So some naive XML parsers will try to build up that entire tree in memory, and then you can just ask that tree for information. As you can imagine, if you have a really big XML document, that builds up a really big tree, and you probably don't want all that in memory at once. So the choice for NSXML parser is that it operates in an event-driven manner. So it reads through the document in a linear fashion, and every time it encounters some interesting part of the XML document, say an opening tag, or a bunch of characters, or a closing tag, it notifies a delegate, hey, I found this. Like I said, specifically, it does not build up the entire tree of the XML. You might, because you need the entire tree, but it doesn't. It assumes that you don't need all of it. You don't need everything. So every time it encounters some part of the document that it thinks is interesting, it will send a message to its delegate. And therefore, it's up to the delegate to figure out what to do with all those events. So two really obvious events: the parser starts the document, the parser ends the document. So you can use this to basically set up any variables you need to keep track of the state that you're parsing out of the XML, and close those down when you're done. Now, most of these methods are kind of annoyingly long, but there's parser did start element, namespace URI, qualified name, and attributes. So again, we'll go through these a little bit. The idea is that it takes in the parser, of course. It takes if it found the opening tag for some element. If there's namespace information available, I'm not a super XML guy, so I don't quite know what that is. But if you know XML and you know that there's some custom namespace thing going on, you can parse it. You can get that from that, and that kind of goes into qualified name as well. And then if there's any attribute key value pairs within that opening tag, it'll include those for you too as a dictionary. And then similarly, when it reaches a closing tag, it calls did end element, and again it includes the element name and any additional namespace information if you need it. And then kind of everything in between the tag is going to call found characters. It basically says, okay, I found a bunch of characters. It's not within the tag, so hopefully it's the contents of some tag. And this is greedy. It will send as many characters as it can until it determines it reaches some other thing. So if you have, say, the open tag string and the closed tag string, and between that you have hello world, it will send everything, not just H or not just hello. It'll send everything between that and whatever the next open or closed tag is. Okay, so let's parse that XML now. Oh boy. Okay, so rather than building up this data string, let's start a parser. So parsers are pretty easy. Just you allocate them and you initialize them with some data, and then since we're not, it will then retain the data so you can safely release it. We're done with the connection, so we can release it, and then we set the parser's delegate to be ourself, and then we say parse, and then it goes off and starts parsing, and then starts sending messages to us when it gets interesting events. Okay, so. First one is the document started. So the way I did this is I have an array of RSS entries, each of which is going to be a dictionary, basically of all the different key value pairs that are in that entry of that RSS feed. So I'm going to first create that. This little bit up here is if this gets called multiple times, I want to release the old RSS entries, but I don't want to release it if there isn't one yet. Just to be safe. And then I keep track of this stack of tags. Obviously, this is kind of implementation dependent on how what actually you want to parse. I think I did this in a pretty general way that it just grabs the entire tree. But this method will get called when we start an element. So when we get a start tag, then the way I think I did this is I have this stack of all of the open tags that we're inside of, because since we know everything is hierarchical, we'll always close the most recently opened tag. So we can use a tag stack to keep track of, like a stack, to keep track of which one we're currently in and which ones are its parents. So that way we know where to insert it once we're done with one. So I just add one to the stack. And then the RSS entries that I'm actually interested in are items. So that there's one item per RSS entry. And so I'm going to make a new dictionary for each one of those. And then if I found some characters, which probably means I'm in between some tag, then if it's one of the ones I'm interested in, which for now I'm just going to grab either the article's title, the link, the description, or the publication date, and if the current tag is one of those, then I'm just going to kind of add that object to the current dictionary. If it's not one of those, then I think that means that I just found some characters. So that just means that needs to be the only object in that current entry. Most of this, if you don't know XML, is a little complicated, but it's not that bad. Okay, so then this gets called every time we exit. We end an element, so I pop one off the stack, and then I add that entry to my list of entries. Okay, then I think I need to hook up this window. Hang on. Is that right? Let's hope that's right. What is the first responder? It is arson. Okay, cool. Let's see if it does that. Oh, right. These are the methods for, oh, come on, for populating the table view. You'll get an example of this in the lab on Thursday, but for iPhone. Yay! Not a very pretty interface, but it kind of gives you the idea of how to grab in that data and then redisplay it. I'll post this sample code to the website so you guys can take a look at it and play with it. So, kind of just in summary, delegation is this very simple, very simple, really, design pattern, and yet it's extremely powerful because it allows really great customization of objects without the need for subclassing. And what's really cool is that it allows a single object to control the behavior of multiple objects. So we have a single source of truth where there's one object that's responsible for controlling a bunch of different objects, rather than having to have one object to control each individual object, which often doesn't make sense if those objects depend on each other. Any questions about delegation? I know it's kind of a broad topic. On Thursday, you'll get a nice hands-on example of doing some delegation for different controls. Cool?